Uh, Hello, dear student. I hope you are fine and doing well. Uh, Today, our lecture is all about linear combinations, which is one of the most important topic in linear algebra, and it has many application in digital media. Like I need to say, it has many application in the image processing and what you call the information security. So let me tell you first how we can uh, say that certain class of vector space element are basically form a linear combination of norms. If I can say, if some vector or one vector can be written as a linear combination of certain vectors, in that case, I can say that that vector is a linear combination of some number of vectors in one vector space. So in that case, if I can say this, I need to say the system has some consistent solution. And consistent solution, as I told you in my uh, previous classes, that it has finite, unique, or infinite many solutions. So let me elaborate this concept with the help of one of the what you call some examples. Today, the topics to be covered is linear combination, example of linear combinations, then some real-time application of linear, what you call the linear. Let me take this one, and then this one, like okay, uh, linear combination. So let us define the linear combination. So first of all, the vector V is a linear combination of some R vectors. That if V can be written as the linear combination of these R vectors. So if I can elaborate this, what we call the matrix multiplication. I can say this, if you can visualize the matrix multiplication as a linear combination, so if you can look over here, this is our first column, this is second, and this is third. If you can multiply this one, and if you can see this one, the first whole column is multiplied by a vector A, and this B and this C. So similarly, if you can see this one, this is multiple C is multiplied with the third column of this one. So you can see over here the matrix multiplication is just a linear combination of this what you call the input element. So this is our output. So this can be written as a linear combination of A, B, and C. So I can say this what we call this matrix multiplication can be written as a linear combination of this column vector, a column of a what you call the given matrix. So if I can let us elaborate this with the formal definition that if a vector V from any vector space is called a linear combination of a given R vectors from 1 to R, it's as follows. That V can be written as a linear combination of R vectors where K1, K2, and K are scalar. So if the system of equation in term of, this is what we call the system of equation in term of KIs, I need to say in term of K. So if the system of equation is consistent, then we can say V is a linear combination of R vector. If we haven't found the consistent solution, in that case, we can say the system is not consistent. Or moreover, as I told you in my previous classes, that uh, consistent solution is has what you call two cases. One is a unique solution, and a second one is infinite man solution. Both are can be incorporated over here. So let me elaborate this with the one of the examples. If I can say whether this polynomial can be expressed as a linear combination of these three polynomials, whether it may be possible or not, let us decide that. Let P can be written as a linear combination of what you call K1, P1, K2, P2, K3, P3. So P is this polynomial of degree 2, K times P2, K2 times P2, and K3 times P3. We just what you call multiply all these polynomials with Ki and uh, take the coefficient with the constant term, and then the coefficient with the x term, and then the coefficient with x square, and compare these with the what you call left hand side. So we'll get the compare the like power of x. We will get this system of equation in terms of ki. So I just transform these into an augmented matrix in order to find out the solution, which is ki. So I just perform row operation given over here in slide 7. I just perform this, and in this slide, if you can see this K3 have this value non-zero, and this K2 and K1. So in that case, these are some unique values. It means the system of equation in terms of Ki, that is this one, is consistent. So in that case, if we can plug this K1, K2, and K3 value over here in this equation, it means this polynomial P can be written as a linear combination of P1, P2, and P3. So if you haven't found these values, I need to say the system in terms of Ki, which is this one, is inconsistent, having no solution. So in that case, dear student, we can say we cannot return P as a linear combination of these three. But here we can see if we have find non-zero value, what we call the system is consistent. Mm, consistent. So in that case, we can say these system with the system in terms of Ki, and then we can express P as a linear combination of P1, P2, and P3. Let us take another example that we have this vector V, whether it can be written as these three polynomials, these three vector or not. Let V is, we have written this linear combination, V is K1, V1, K2, V2, K3, V3. Then we just put all these vectors V, K1, V1, V2, V3, and thus multiply this with each the order pair, order triplet with K, and then what you call and corresponding x component is added in x, and y component is added in y component, and then z component is added in z, and then we compare x component of this order pair with this one, and y component, which is 11, with y component of right hand side, and then left hand side third component, which is z component, with the third component of right hand side. In that case, we will get system of equation in term of Ki, and we just solve this again with the help of Eckland or reduced Eckland form in order to find out this. In that case, if you can see from this one, so we get K3 1, K2 is -5, and K1 is 4. In that case, it means K1, which is we just put all these K1, K2, K3 in this previous equation here. If you can multiply all these, you can get 6, 11, and 6, which prove that our result with is our vector V can be written as a linear combination of V1, V2, and V3. Let me explain this with the help of another example from matrices. Determine whether these matrices, this is a linear combination of these given three matrices in the vector space of 2 by 2 matrices. Let us suppose in terms of vector we have three vectors, K1. Here not V1, we will put this matrix before we are in a matrix algebra. K2 and this matrix, and K3 with this matrix, and written as this one, because we need to find out whether this can be written as a linear combination of this one or this. So we multiply each K with this matrix, K2 with the second one, and then add this matrix, we will get this one. So we compare because two matrices are equal, then its corresponding component are same. In that case, we will get four equation in terms of K1, K2, and K3. if you can see over here. So we solve these equations, we will get k1 3, k2 minus 2, and k3 is 1. In that case, we can say this matrix can be written as these three vectors, provided that k1 is 3, k2 is minus 2, and k3 is 1. So these are what we call consistent system with respect to ki's. Let me elaborate another example that whether these three vectors can be written as a linear combination of this W. So let W can be written as C1 V1 plus C2 V2 and C3 V3. It can be K1 K2 K3 K3. I just celebrate this with C1 C2 C3. So if we can transform this into a augmented matrix, so if we solve this, reduce this system into a echelon form, so ultimately our last row is zero, which means that the system is inconsistent with respect to Ci, because it has C1, C2 value, but C3 does not exist over here. In that case, the case 0 is not equal to 7. This case exists, and in that case, we can say the solution. There is no solution. So W cannot be written as a linear combination of these vectors. So these are some what you call mathematical definitions of linear combination. There are numerous applications of linear combination. Let me elaborate that different kind of colors are in the form of linear combination in color model. If you can see over here, this is RGB. There are different kind of images like RGB. These are used in media, digital media, and CY and K. This is can, yellow, magenta, and what you call magenta, yellow, can, and this is what we call the linear combination of all these ones. So if you can see over here, these are two models, and these all these what you call different models, and over here different colors can be generated with these three possible linear combination of the red, green, and blue color. And with these, you can see this different color can be generated with magenta, yellow, and can, the linear combination. This is basically the linear combination of can and magenta, and this is color is generated with the help of yellow and can, and this is again the what you call the this color is generated with the linear combination of what you call yellow and magenta. So let me elaborate this with the help of one example. That is, there are two kind of models. That is additive, like RGB, and subtractive, like CMY. Is it subtractive model, and basically printing ink uses the CMYK, and whereas the uh, uh, um, additive models are used in light to display color, like RGB color used in software, UI designing, and many more. So let us define this with unit cube. That is red, green, and blue are placed over here, and all other color are the linear combination of these three colors. Whereas if you can see this magenta, can, yellow, and black. These are what we call the basic four things. All other are linear combination of these colors in this model CYM. So where actually we are using RGB colors. Basically, our TV light cathode rays and these all and like our tab mobiles are utilizing these what we call the RGB colors, electronic media, and in print media use CMYK model. Like similarly, if you can see this, this is our every what you call the in additive model, the every colors are ranging from 0 to 255 in term of 8 bits. So red color is can be written as this one, 25500, then green 0 255 0, and then blue 0 0 255. So how can generate other color with these possible linear combination. So let me tell you that any color can be written as the linear combination of these three color R, G, B, where K1, K2, K3 are the three scalar which you can set with respect to your what you call requirement. So W is your generated color through the linear combination of RGB. Let me elaborate this with, if I said this is R, this is G and B, and I said K 0.6, K2 is 0 and K3 is 0.8, then the linear combination of these colors is 153, then 0, then 204. Then in that case, if you can see this one, this is our purple color. I just draw this with the help of one of the software. Uh, so if you can see the linear combination CMYK, that kind magenta, yellow, and the key or black color. Though in that case, in this color model, the any color which you are going to generate, which is W, can be written as a linear combination of four color, and where N1, N2, N3, and N4 are what you call four scalars. So if I can say magenta is 100, then so can is 100, magenta, yellow, I take these four possible tuples, and I put N 0.5 and 2 0.3. These are what you call, I just giving you some demonstration. You don't, you have to go into detail of this, but I just give you some realistic, what you call, uh, uh, application of linear combination, how linear combination is helpful in image processing. So if you can see over here, if I can say 0.5 and 2 is 0.3 and 3 is 0 and 4 is 0.01. In that case, if you can see this, we have generate this one. This is purely sky blue color. That is C is 50, M is 30, Y is 0, and K is 5. In that case, you generate sky blue color. Dear students, these are some of the real-time application of what we call linear combination. And thank you all, and may Allah bless you all. And till then, Allah Hafiz.